Hi everyone, and welcome to another restoration at Mr. Carlson's lab. Let's get started. Welcome back to this restoration journey that we're on here together with this General Electric radio receiver. So the amplifier and power supply has been done at this point, and that's been completely restored as you've previously seen. So now what we're going to do is take a look at the RF portion of this radio receiver. So all I have to do is remove some screws on the bottom side of the case here, and this whole chassis will just come out. I can get this big, huge radio receiver case off the desk here. So what we'll do is we'll take a really close look at what we're up against in this chassis, take a look at the schematic, and all sorts of great stuff. So I'll get this happening, and I'll be right back. 6 screws have been removed from the bottom. And it's ready to come out. All right, the chassis is out, and from what I can see so far is it's going to need some compressed air to get rid of the dust. There's quite a layer of dust on here. The rubber, as you can see this here, little rubber washers that isolate the tuning mechanism from the chassis are in very nice condition still. So the rubber is nice and soft. Same with the chassis mounts. So they just need to be cleaned up. They're very soft. They feel, just like they probably did when they rolled off the floor. I can't imagine them feeling any better than that. So that is nice. I don't know the condition of the tubes, so they look all original here. I'll zoom in just a little bit. So you can see that these are, General Electric tubes. And this little one here, you can see right here, General Electric, right there. They look to be all original. And the one right out the front here, most likely the mixer. Yeah, everything looks General Electric. I'd have to pop the shields off of these ones here to see if they're General Electric as well. So, all in all, since this is a turret type assembly, it really has simplified the way that this thing functions, and actually even the restoration of this portion. So this should go very quickly for me, which will be very nice. So what I'll do here is I'll get you onto the underside of the chassis. I'll turn this around so you can see this here. Just before I do that, these are the alignment points right here, here, and there. So as you turn the turret assembly, so as you're changing bands, it puts all the alignment points right at 12 o'clock, or right up and down. So talk about making the alignment easy. Wow, that is very nice. So I'll end up cleaning the chassis of this off again with, it was just like I did with the audio amplifier. It was very simple, basically a kitchen scouring pad and some water. And it just made the chassis look like brand spanking new. So the chassis itself is in very nice condition. I have to be careful around the writing here. I'll just tip this up so you can see the writing. Back that out a bit. I have to be careful around this because I kind of want to preserve that. If it does come off, well, it comes off. But I was very, very careful with the amplifier around this to try and keep the writing all on there. So what I'll do here is turn this around so you can see the front without the actual dial glass. Nice and clean. This should be very easy to actually clean up. You can see they have a rubber gasket around this. And that rubber gasket mates to the front of the unit, so it's done a really nice job keeping all the dust and debris off of the dial. They really didn't spare any money on this thing. It's just things just like this little rubber gasket to keep dust out of this. It's just the thought process. And wait till you see what I'm about to show you here in just a moment. Building something like this nowadays the cost would be astronomical. Just because of all the mechanics and everything. I'll flip this around here and I'll show you this here in just a moment. So it's little things like this that just make you really realize the difference in time. So when I say this, what I'm talking about is you can see the front end of this. First of all, they've included a tool to help you service your own equipment. Where do you see that nowadays? It seems to be the complete opposite thinking. They're saying, oh, okay, if they need to align the gearing on the front of this, we'll include an Allen type wrench on here so that they can do that. That right there just tells you that this is a complete different way of thinking in this. They're using brass gears. You don't see anything plastic in there, stuff that's going to end up wearing out. And as you can see, they're in perfect condition. This here is the little light box. So basically there's a a lamp in the middle of this, an incandescent type bulb. And what it does is it shines through these little plastic pieces here, which act as light pipes. And what it does is, as you're tuning the dial, these things rotate and it shines light in each one of these little bands as you turn this. So it lights up the dial of interest, at least the dial that you're listening to. So if you see right in here, you see all these little pieces of plastic in there? That's all the light pipes. And this will shine in each one of those as the turret assemblies move. So I'll just grab the actual turret assembly and move this. So you can see that, how it focuses in each one. And that lights up each one of these little bands right here. So the thought process in here is just incredible. So Hammarlund, back in the days of the SP600, had a turret type assembly. And that's what they've done in here. And that's the reason that all the alignment points come right to the top. So two things that really tell me this, beyond this, all right, is I'll just move this around here. Again, only two hands, so pardon the camera movement and everything here. I'm trying to keep you in the loop here the best that I can. So looking at this, looking at a monitor, moving this around, everything is quite a handful. So you can see in this design, this is a 6C4, so they're using a 6C4 as an oscillator, and they're using a 6BE6 on the other side here as a mixer. Same idea as the Hammarlund SP600. They have a turret type assembly in here where all the alignment points come to the top. Everything, again, SP600 style design there. Even in the bottom, the design is, somewhat similar. They're using on the bottom here. Just move this around, tip this over. Just the way that they've assembled this whole thing and the way that it makes contact in here. All of these little, as you can see, these little stubs here are electrical contacts which bring this assembly that you see right here into contact with everything. So we have, basically an oscillator, an RF section, and an antenna section. Each one of them is tuned. So as this goes around, this makes contact with little fingers at the top here. And these are actually in very nice condition. They're hardly even, I guess you could say, tarnished. This is going to be a very, very quick and easy restoration for this portion, and that's what they want. They want this thing to be serviceable. Again, they want it to be so serviceable that they're including tools on the front to help you fix your own gear. So what I'm going to do here is I'm just going to move the camera around, and we'll take a really good look at the bottom portion of this, and I'll go grab a schematic for this out of my files, and we'll take a look at the schematic and compare to what we see here. Here's a better look at the bottom, and as you can see, it's really in nice condition. I think this radio has low time. It just doesn't look like there's a whole lot of time on this thing, which is nice because it just brings us even closer to a more accurate representation of how this thing performed way back when. So you can see right here, immediately I see these pink capacitors. They're tiny chief capacitors. I don't know if you can see that there. I'll zoom in on that. So tiny chief, I like to call these tiny grief capacitors because they are incredibly electrically leaky. So I don't know if I've displayed this before in the past. I know I worked on a bunch of MAAS amplifiers. I actually redesigned them, and they were full of these things. I may have displayed that back then. It might have even have been before my capacitor tester. So this is going back quite some time now. So these will have to go. So these are definitely going to be bad. You can see that they're using tons of disc type capacitors in here. Again, same kind of thought process as the Hammarlund SP600. You can see the thought in the shielding here to stop this from interfering with the IF section. So they're basically trying to stop any type of oscillation. So they don't want one section to hear another section. That's the reason they're putting this in. Right down to the point to where they're actually notching the shielding so parts can go through. Flywheel down to the bottom here. I'll just back this out. You see a flywheel, so it's weighted. So nice heavy flywheel. So as you move this, as you move the dial on the top, you can see it's nice and weighted. So when this is all cleaned up and relubricated, that'll make that dial just as smooth. It already is smooth, but it'll make it even better. These are the IF transformers here. You can see IF transformers on the bottom. So there will be a slug in the bottom and a slug in the top. So what a slug is well, known as a powdered iron slug, is in an adjustment point. And what they do is they move the powdered iron slug up and down inside a coil form in order to adjust the frequency of the IF transformer. So in this case, I believe it's 455. Most likely is. By this time, 455 was kind of given up. Let's see here. Second IF, first IF. Yeah, I'll have to look that up. I'm pretty sure it's going to be 455 on the schematic here. So you can see the location at the top here. So this is the schematic for the receiver, and it's very nicely laid out. It's 2 pages, and what I do is I cut the pages and put them together. So basically I make sure the sizing of both pages are the same and then cut them and put them together. So if not, what they do is they leave these lines really long right here. So basically just some trimming on a board. And then of course making the pages the same size helps everything line up. So that works out very well. So you get a really nice complete schematic. So you can see the 6C4 oscillator up here, a triode oscillator. So a lot of All-American 5 and All-American 6 radios, they use the 6B6 as an oscillator and a mixer all in one tube. Well, using the 6B6 as a mixer and separating the oscillator really optimizes on everything. The 6C4 really works well as a high-frequency oscillator, and the better the oscillator works at higher frequencies, the better this receiver is going to perform. The 6BE6 is a very good mixer. A lot of people seem to think that it isn't. It's good enough that they use them in military receivers as mixers, i.e. the Hammerland SP600. We have a standard type of IF chain. We have 2 6BA6 tubes, so we have the first IF and the second IF. And they're using a 6AL5 as a detector and the AVC over here. So basically what's happening is they're using this as an envelope type detector for AM and an automatic voltage control, which automatically controls the gain of all of these stages. So when you have a really, really big signal, it lowers the gain of this whole section down. And then when the signals go weak, it allows it to hear again. So it's basically almost like a feedback loop happening here, and it keeps the gain just right at the right level. So that's what an AVC tube. Automatic voltage control, sometimes known as an automatic gain control, just depends on the manufacturer. We have a 6U5 and a 6G5 tuning indicator tube, and that's the tuning indicator that's on the top side of the chassis here. So that's this tube right here on the top side. And a lot of the times, most of the time, they're pretty tired. So usually what happens is the material on the target wears out, right? They're usually operated pretty hard to make them nice and bright, right? Because, you know, that was a thing way back in the day, is to have a nice bright green eye in here. A lot of the times they had a lid on them, so sometimes known as an eyelid. They would have that on the top here, so you'd only see the one portion of the 6G5 because there only is one shadow angle basically in here. They have, how to explain this? Well, you'll see in the end. Basically, there's only one portion that opens and closes. So you have really only one area that's doing the deflection, whereas in other radio receivers where you'd have a tube like a 6AF6, like in my DeForest radio receiver restoration, it has 2 shadow angles. So you have one on the bottom and one on the top. So you just get double the action. So this is only a single action tube like the 6E5. So the 6G5 and 6E5 and 6. Oh, there's so many different ones. Well, I'll demonstrate that later. I'll just show you that. And I'll cover all of that then. So this is the IF tube chain right here. So this is the IF, one IF tube here, another IF tube right here. And we have the detector and the AVC tube right over here. And so we can see that this is going to be the oscillator, this is going to be the RF section, and this is going to be the antenna tuning section right over here. So we have a 3-gang type tuner here. This is going to be the RF amplifier tube under here. Let's just see if this is a General Electric tube as well. So these are usually pretty stuck at this point, and they are. Let me just see if I can poke this out of here. So I'll put the plastic tool on the top and push on the tube and see if I can get this out. Sometimes they're pretty stuck. Yeah, you can feel that in there. It's pretty stuck. So, yep, it is the General Electric tube. So, one really nice thing about the 6BC5 tube is it has a very large cathode area, and they make great RF amplifier tubes. Again, the General Electric engineers know what they're doing. Tubes like the 6BC5, 6CB6, 6EW6, all those types of tubes with a very large cathode area make extremely nice RF amplifier tubes, and IF amplifier tubes for that matter as well. One of these days in the future, what I'm going to do is I'm going to go over tubes with all of you and tell you what their service really is optimized, and if you want to build anything with a vacuum tube, where they should go. So there's all sorts of different types of tubes that you've probably never heard about, and the audio guys haven't gotten their hands on them yet. When I explain this, it'll clarify a lot of stuff about vacuum tubes for you, and you'll be able to understand and choose, say, vacuum tubes out of your junk box and go, okay, this will be good for this service, right? You can, a lot of these glass tubes you can just tell by looking through the glass at the internal structure. So you can see on the top side of the chassis here, pardon the road noise, there is some road noise around here today. And I'm trying to talk over top of it. You'll hear it here in a moment. So lots of large trucks moving around here. So you'll see here, they've got some copper strips. I don't know if you can see that. Trying to look in the monitor and do this all at once here. So you can see the copper strips here. It's nice that this doesn't have to be removed because they've spot welded these copper strips down here. So that would make for removal rather difficult. So that's nice that the rubber, the actual rubber grommets and everything on this upper side are in very nice condition. Again, you know what? They didn't spare any cost on this thing. Even the rubber is still good. Most of the rubber on all of this stuff just absolutely decays by now. The rubber is still soft. So it's they just used the best parts that they could find for this thing. And, you know, this really is a testament to just the way that they used to think before. So getting the eye tube out of this, I'll show you this right here. And this is pretty standard for most tubes, eye indicator tubes, is just this here. You can undo this and take the whole mechanism off, or you can just stick your fingers under here and pop this sideways and this will just come right out. So I'll just show you this right now. This is actually probably pretty stuck. Yeah, it's actually stuck in the clip, so I don't want to be prying it because this is up against a metal thing here. So all you would do in this case is get a pair of pliers and just twist this, and this just unscrews, and the whole eye tube mechanism will just come right off. We'll see if I can get a pair of pliers on here and just give this a twist. There it is. All right, and then as you can see, it just comes right out. So, and it allows you to slide this up and down and get it just perfect. So you can slide this to get it nice and straight on, and then of course move this back and forth like this. And this looks like it's on a bit of an angle, so they could have done a bit better. They could have slid this a little more forward into the bracket. So what I'll do is I'll make sure that this is perfectly level when I most likely replace the eye tube. I haven't tested this. Again, this has had no power applied to it. So we'll see how bright this is, and if it's weak, I'll replace the eye tube. In fact, I like the action of the 6E5 a little better than the 6U5. The 6U5 isn't as sensitive, so I might replace it with a 6E5. Another little trick I'll share with you here in a little bit. Direct replacement, much more sensitive. So it just depends on how strong the AVC and AGC line is. So we'll check all that out. What else can I show you here? We'll get back to the schematic here. So what else can I show you on the top side? So IF transformers right here, IF transformer, and then we have the basically the coupling transformer. So yeah, 455, you can see that right here, right? 455 kcs. So IF transformers, and the coupling transformer would be this one here, right? So this is going to be coupling to the detector and AVC. So basically mixer to first IF transformer, first IF to second IF transformer, and then second IF transformer to the detector and AVC, which would be right here. And let's see, what else can I tell you here? Let's look on the bottom. Let's see what these are. This is most likely going to be the antenna transformer here. Let's see, so 6BC5. Yeah, this is most likely going to be all of this here. Right. Lots of transformers all over the place here. And yeah, so diode output, again, see that diode output right there? It's SP600 everywhere. on this thing. So we know what the General Electric engineers were doing. They're going, hey, Hammarlund's onto something here. Let's copy them. Because you know General Electric engineers copied Hammarlund and not the other way around. So let's see, what else can I tell you here? All the resistors in the bottom side here are squared off type Allen Bradleys. So I'll just zoom on in, and hopefully the light is good enough. It looks like it is. So squared off type Allen Bradleys. There's a lot of high value resistors here, so I'll end up testing those like I did in the amplifier for noise. So you can see all of this here. Right, they're all squared off types. So it's looking really good at this point. Lots of disc caps that don't need to be changed. These are mica capacitors. They don't need to be changed. The smaller type micas, which you don't see all that often, are in here. We have ceramic type capacitors here, which these are chosen because they have certain temperature coefficients. Let's put it that way. So these are temperature compensating. You can see that they're in, you can see this one down in here. Right, so ceramic tubular capacitors is what they are. And sometimes they'll have an N value, all right? So they're designed to drift in certain directions, some of them are. So if certain components are going in one direction, if they drift with temperature in one direction, this will drift in the exact opposite direction to compensate for frequency drift. So figuring this stuff out is what takes the engineers a lot of time. So these ones here, mica capacitors, are usually just stable, all right? So they will move just a little bit, but other capacitors are designed to drift in one direction. In some cases, again, you'll see an N number beside it. And if you're going to replace capacitors, say you're going to replace these, you would definitely need to know that, because if you replace that with a capacitor that might be stable like this, if something's drifting in this in one direction and you replace it with a capacitor that doesn't compensate in the opposite way, you'll get frequency drift again. So the rule of thumb is when you see capacitors like this, usually they don't fail. Okay, so they just don't fail. They're always good. I have never come across one of these things that's bad. Mica capacitors, yes. So when there's high voltage on one side of it and on the other side there isn't, sometimes they do fail, especially when they use them in audio service across the output transformer. As again, as I explained in the audio video, that they put those capacitors across the transformer snubbers. So when they use these type of capacitors in snubbing service, yeah, they do fail because they end up arcing inside and creating a carbon path. All right, so these rarely fail. Okay, again, with these things, if you don't have to replace them, you don't want to replace these, because if you do replace them, you would replace this with something like a modern NP0 type capacitor. These, again, you don't want to touch these unless absolutely necessary. And as I said, I've never come across one of them that's bad. On the other side, you can see that we have one of our famous, let's move this so it doesn't go flying again. One of our famous Black Beauty capacitors waiting to just destroy something. So I didn't mention this in the audio video, so a little tidbit going backwards in time now. These things are the reason that audio transformer went. So one of the Black Beauties was leaking so bad that it was causing the output tube, one of them, to turn on so heavily, probably the one that was sparking, that it had opened a winding in the transformer. These things here were created by the devil. These things are bad news. These things have got to go. These Black Beauties, they just destroy equipment. And any of you guitar guys, oops, shine this up here. Any of you guitar guys that are thinking of leaving these things in your amplifier, if there's no high voltage across these things, who really cares, right? So they're turning into resistors any way you look at it, but if there's high voltage across it and it's a coupling capacitor, these things are just going to destroy your stuff. And don't let anybody brainwash you into thinking that these things are going to give you better sound, unless of course you like to listen to your audio transformer frying. So that's kind of a crackly noise, by the way. If you like that, if you want to add crackly noise to your guitar playing, yeah, there you go. Garbage, pure garbage. These have got to go. These are the oil-filled versions. As you can see, there's a pipe here, and they fill these things with oil through the pipe, and then once they're filled, they solder them up. So that's the pipe style one. Some of these are just paper and foil, and some of these are paper and foil in oil. This is the in oil version, and this one hasn't leaked, which is kind of nice. It hasn't leaked physically, but it is 100% going to be leaking electrically. Okay, garbage. Let's see what else. Disc capacitors, nice. These won't need to be replaced because those rarely fail as well. Another adjustment point here that we'll have to look at the schematic to adjust during the alignment. We're going to do the entire alignment together. So I won't go through every single band. I'll give you an example of one band, and all the rest of them are the same. So I'll save you all of that tedium. And that's it. That's pretty much it for the bottom side here and the schematic. So let's see here. What can I show you? Oh, I don't think I've ever shown you one of these tiny grief capacitors. Let's see here. I don't think I've ever shown you this. So I'll just show you this right now. So if I haven't displayed this, I always like to display this. I've shown you leaky bumblebees before. So what I'm going to do is I'm going to clip this one lead right over here. I can get this in here. And I'll just move this out of the way so that I can connect it. You can't test capacitors like this for leakage in circuit because the rest of the circuit will drag it down, drag the leakage tester down. So I'm just moving things around here. So what I'll do is I will attach this to here. It looks like it's attached to here. Put this here and put this up here. Okay, so this is the sense lead. All right, and I don't want the sense lead to touch anything because this is an extremely sensitive tester. Again, I designed this thing for purpose, basically to find a bad transmitting capacitor in a large transmitter, and nothing else would find it. And I had to design a piece of equipment to look for this, and it found it. So at any rate, I've released this thing on Patreon and all the designs and schematics and everything. So you can, at the end of the video, I'll explain how you can get there if you're interested in this thing. So here we go. Let's see what happens. So this, what this should do is this should count down on the scale, and then it'll be red, which means it's very bad. And then if it goes past the red scale, it'll pop over to a yellow scale, which means that it's getting closer to having extremely low leakage. And if it comes down here and goes to a green light, then you know green means that it's going to be okay. Okay. And look at this. Okay, that's how incredibly bad that capacitor is. So that's 0.047, all right? So this is, we're in the megohms right now. So this would be 1 gigohm here, and when it flips to the scale here in the forecast, this is 1 gigohm, and that's 40 gigohms at this end here. And the reason that it's such high resistance is because this is testing this with a lower voltage, okay? So that capacitor is incredibly bad. So what I'll do here is quickly give you an example with another 0.047. Which is the value of that capacitor. I believe this one is, yes. Okay, so I'll just move this off of here. Okay, and that's me holding the clips. It's sensing me just by holding the actual clips. So what I'll do is I'll turn this back into the, actually I'll just shut it off here and I'll put this on. Okay, put this on here and I'll hold this down here because I don't want to touch the clips because it'll read me. Okay. So there you go. Now this is the same value as this one up here. Okay, so this is a good one here now. Now keep an eye on this. Now this is in the forecast position. And that's the reason that it's taking so long. That'll switch to green here in just a moment. There you go. So that's a 0.047. And that's extremely sensitive. The reason that this is a forecast position is it kind of gives you an idea if the thing is going to fail down the road. Okay, so what we'll do here is I'll turn this off and I'll turn this on to just the normal test for one of these things. All right, so here we go. You can see how fast that moves down with just a normal test. So this isn't the forecast test. You'll see a buzz through that scale. Okay. Whereas again, if we go back up to this one here, so I'll put this back on here again, and then I'll put this to the open lead up here and keep that off. I don't want that touching anything. There we go. So that again, this is just the normal test. And as you can see, it's stuck on the red scale. extremely bad capacitors. So these things destroy amps. Those MAAS amplifiers, those they use them in churches. They use those amplifiers in churches. They absolutely destroyed those amplifiers. So anyways, I talked about that a little bit way back when. So anyways, I won't get into that. If you're interested in this thing, again, it's all the plans and designs and printed circuit board layouts and everything are all on Patreon. You can check that out. Took quite a bit of time to design this and put this together, and I'm sure you'll appreciate building one of these things. Many people have built these and shared their stories about them. So they're a fantastic device to have. I use this thing all the time, especially when you come across capacitors and you're unsure of what's inside. This gives you an idea of what's inside. Okay, there you have it. So what I'm going to do now is I'm going to go through this thing and I'm going to recap the bottom side here and test components. And in the next video, in the next portion, we'll get right to the alignment and we'll try the thing out, see how well this receives. I am extremely excited about this thing. This receiver is such a neat device. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So if you haven't subscribed, now would be a good time to do that as well. If you'd like to be notified as soon as I post a new video, don't forget to tap that bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the Show More tab below the video's description, and I'll also pin the link at the top of the comments section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.